Our next presentation is by Zoe Kloth. We've got damming factors affecting long-term stability of the Lake Conestee Superfund Site. Thank you.
Well, hey everybody. So I focused my senior research project on Lake Conestee, which is in Greenville, South Carolina, and it is a Superfund site. All right, so when you hear the term Superfund, you're probably picturing hazmat suits, maybe barbed wire fences and signs, all designed to keep you out. So when I visited Lake Conestee for the first time, I was really surprised to see wildlife, plants, boardwalks, and nature trails all designed to bring you in. So this site is really unique for two reasons. First, it contains a contaminant profile that's a lot more complex and diverse than most other Superfund sites. And then second, the management strategy used by the Conestee Foundation to manage the Superfund site is really unique because unlike a lot of other places, it's a Superfund, but it's also a nature park. So the map in the upper left-hand corner gives you an idea where it is. Lake Conestee, let's see, I can do the laser. It's about right here. So in the middle of Greenville County, it's fed by the Reedy River, which extends down the entire length of Greenville County, and also the Marrowbone Creek, which is its main tributary. It sits about 8 miles south of downtown Greenville, and it's surrounded by 2 airports and then a bunch of developed areas and highways, some of which even cross over the Reedy River. So when you're looking at where it's situated within the county, it really isn't surprising that tons and tons of contaminants and also sediment have accumulated in this site, causing the problem that we have today. So this is a map of the park. As you can see, Lake Conestee is surrounded by a network of nature trails and observation posts. But first and foremost, it is a Superfund site, and that's the main thing to consider with the management of this area. And so there are areas where exposed sediment and water show elevated levels of contamination, but most of the problem that exists at this site exists in submerged sediments. So the Superfund, the problem here was created by contaminants leaching onto the sediment that was carried down by the river, and it accumulated behind the Lake Conestee Dam, which is circled in red. So basically you have tons of sediments and contaminants that are accumulated for the past about 125 years. Like I said before, the site's unique because it contains a lot of really bad stuff. I know this is a busy table, but these are all the contaminants that you can find here. The ones highlighted in yellow are the substances that exceed the permissible exposure limits, and those levels are set by OSHA, the Occupational Safety and Health Administration. So basically what this table's showing you, and on the left-hand side you have frequency of detection, so how many times these contaminants were found, and the 53 sediment samples that were collected from various areas of the lake. You have your maximum and then your average concentrations of the contaminants. And then over here on the PEL column, you have how these concentrations compare with the legal limits set by OSHA. So the substances circled in red are the ones where even just the average samples exceed the permissible exposure limits. And just to give you an idea of the quantity that we're talking here, so chromium, which is just one of the ones listed, there's over 1 million pounds of it at this site. So really you could mine chromium for profit here. And that's, again, that's just one of the contaminants found. And with this project, the key feature of this site is the Conestee Mill Stand. Without it, there wouldn't be a lake and we wouldn't have a Superfund today. It was built in 1892, and when it was originally constructed, the mill pond was about 130 acres. And for a lot of other sites, dam removal would probably be the selected option. They would drain it, they'd dredge all the bad stuff out, and essentially they'd take it away and bury it in a lined landfill. This really isn't an option here. So the Conestee Foundation, they employed a really unique strategy, and it was encapsulation and on-site monitoring. So basically, they're letting the river do its job. The river performs 3 natural functions: erosion, transportation, and deposition. And as long as this dam stays in place, if you kind of think about it as a bathtub, all the bad stuff is at the bottom, started accumulating when the dam was first built, and the river is continuously flowing water and clean sediment over the bad stuff, and it's capping it in place. So as long as the structural integrity is maintained, you can contain all the contaminants there, and you're able to see how nature is essentially recovered from a lot of environmental damage. So my research, part of my research focused on the rate at which Lake Conestee was filled. In this picture on the left, you can see how just an average rainfall, our river is turned brown, and that's due to all the stuff that's being carried down with it. So that's essentially what happened, turning this lake, or this site, into a lake to essentially a wetland area. When the dam was built in 1892, it was about 130 acres of water, and over time it's filled up to where it's almost all sediment and only about 20 acres of water. And as you can see from the graph above, it started filling at a pretty steady rate, and then there's a big spike, and what's kind of interesting is that's after the post-World War II construction. So you have I-85, the Donaldson Air Force Base, and you can imagine that not only was there tons of sediment and dirt being washed downstream, but anything that's toxic that was used for those construction projects. So what I did to calculate this, I used historic aerial photography and then also historic satellite imagery in Google Earth Pro. And I was able to overlay the historic 1892 border on top of current satellite images of the lake and just measure how it's filled in over time. On the top picture, you have the original 1892 perimeter of the lake, and then the green one is 2010. So it's decreased even more since then, but you can really see how this landscape has absolutely transformed within not really that long of a time period. So the second part of my research, I looked at the risks associated with dam removal at this site. And to do this, I used an erosion event which occurred in 2000 and 2001 as kind of a case study. So in 2000, in about June, the penstock gave way, and it's pictured in the upper left corner. So basically this was just a gate on the lower part of the dam. And it created a hole that was about 7 feet in diameter. And that's pretty small considering that the dam is about 531 feet long and 28 feet high. So it's about the size of a person. And this relatively small hole that was created, it's pretty significant because tiny hole in 1 year's time eroded 92,000 cubic yards of sediment. And what's even more surprising about this is that it was actually a drought when this occurred. So you have rainfall data up above from October 2000 to April 2001. And what it shows is that the largest flood that occurred during this time period was 1,200 cubic feet per second, which is really nothing considering the amount of rainfall and the type of flooding that South Carolina receives. So a very small rainfall event with a very small damage done to the dam was able to erode tons and tons of sediment. You can see the channel that was carved, which is actually about 6 feet deep in the river. And much of the lake was drained, and then a couple hundred feet up the river was also drained. So to get an idea of how often that type of flood, which is the peak up there, would occur, I constructed a flood recurrence interval using data from this site from 1942 until 2014. And essentially what I found was the most serious flood that caused all this damage occurs on about an annual basis. If you're not familiar with what a flood recurrence interval is, a lot of times you've heard the term a 50-year or 100-year flood. And basically it's a statement of probability stating that based on the normal activity in this area, a flood of this size has a probability of occurring once every 50 years. So it's not definite. It doesn't mean that it will occur every 50 years on the dot, but based on what our situation is, that's about how often it occurs. So a 50-year flood would be about 5,500 cubic feet per second, which is up here. The one in 2000 is all the way down here. So it kind of gives you a picture of just how common this type of risk can occur. So when you're looking at this, really what I found from this research is that, again, due to the toxicity of the contaminants present at the site, dam removal really is not an option. And maintaining the structural integrity of both the dam and the riverbanks is really critical to ensuring the water quality. Any damage to the riverbanks or dam, which would allow contaminated sediment to wash downstream, would directly affect 3 counties in South Carolina, which I've highlighted in red up there. So that would be Greenville County, Lawrence County, and Greenwood. But really any of the counties that touch the Reedy River could be impacted. Again, current fill rates suggest that the lake will be completely full in about 30 years. So the current management strategies that we have are great for now, but once the lake is 100% full, then you're going to have to account for all the sediment that washes over the top of the dam. So we'll have to start brainstorming some strategies for that before it occurs. And also, flood recurrence interval data, it shows that minimal floods that cause a lot of damage, they happen pretty often. If that same hole was present when we had normal rainfall or even some of the big floods like we experienced this past October, the damage could have easily been 2 or 3 times worse, and it would have affected a lot more people. So there's a lot of challenges with managing this site. You have to, there's a lot of risk that exists all the time, and it just gets a little bit more challenging as time goes on. We have a dam that's about 125 years old. They don't last forever, so you're going to have to repair it or replace it eventually. And as sediment continues to build up behind it, we have increased stress on the dam, and then any big flooding also increases the risk. So failure is not an option for the site. Thank you. You guys have any questions?
Was there actually any ecological damage that was reported downstream, or was it just the sediment transport?
There was ecological damage. So the Conestee Foundation, they bought this site from a private landowner in 2000. And so after the event that happened in 2001, they did 5 years of studies. And I can't remember off the top of my head what the exact estimates were. But sediment itself is a contaminant, so that's clouding up the rivers, which impact everything that lives in it, along with the water quality that we use. So there was damage to aquatic life as well.
So did they fix the hole after this event?
Yes, they did.
Okay.
So private contractor, and I had a picture, I guess I forgot to put it in the final version.
It's there, it's the bottom. You can back up.
Let's see. Okay, so that's them working on it. But so the hole drained a ton of water and sediment. So they would have been submerged by water. They could actually stand where the lake was. And basically they just made a wooden patch. So it was an 8x8 patch, a little bit wider than the hole. And they placed it behind the dam, and gravity and pressure from the water holds it in place. Anyone else?
Thank you so much.